Alright, good evening everyone. So, while waiting for the rest to come in, whether they come in or not, as usual, the lessons is being recorded. You guys can hear me, right? So I'm actually using my laptop to talk, but then the video is not so good today, so I'm actually using another tablet to have a look at the whole entire lesson. So can you all please enter the class point first from the very beginning? Because today I already mentioned that we're going to be discussing the question more, all right, for gas laws. All right, so while waiting for the rest, can you all please enter class point? Those of you who want to enter class point via laptop also can on laptop and desktop still can be entered. And try not to use initials. Okay. I'm wondering, is it Ian or I am? Right, so please enter class point. I hope you have. Did you guys actually listen to the videos that I asked you guys to watch before today's lesson?
Yes, I
Thank
did.
you.
It was a very nice video, Che. I
The
like
video.
the I like the way you make us memorize the Prince Charles one. It caught me off guard.
But then that's why the other time when Queen Elizabeth passed away and he's no longer a prince, he's a king right now. So I was like thinking, how am I gonna change this? So that video was recorded like I think 2013 or 2015. So it's still applicable right now, lah, thankfully. May I know who's A? Okay, so I have 18 people. Alright, A is Daniel. IAM is Ian or someone else? Okay. Alright. Okay, so there are 17 people, so I guess, yeah, that's about it. So in case your friend comes in and wants to enter class point, tell them the class point code is at the top part here. Okay, so I'm gonna start already right now. Alright, so a quick recap on the gas laws. There's 3 gas laws that we're gonna be talking about. We have the Boyles Law, Charles Law, and Pressure Law. So in this situation, okay, first thing first, Boyles Law. For those of you who actually watched the video, a quick recap that we're gonna be doing right now. Boyle's law, how I usually memorize Boyle's law is actually by the word boil. Alright, so boil, which means we boil the water and the water boils at the boiling point. Okay, and at boiling point, the temperature is actually fixed, alright, at 100 degrees Celsius. So at 100 degrees Celsius, the boiling point, the temperature is constant. So for Boyle's law, the way I memorize it is that the temperature is constant for Boyle's law. Okay, so in this case, all right, so pressure will be inversely proportionate to the volume. Now, throughout this subtopic, all right, throughout this subtopic of gas law, we talk about pressure. Let me take out one screen for a while. Okay, in this subtopic, actually, for gas law, we talk about pressure, the gas pressure to be more exact. All right, and then we talk about gas temperature, and also we talk about the gas volume. And it is all interrelated to the kinetic theory of the molecules, right? You have to understand on how the atoms are moving. Don't just memorize how don't just go and memorize like Boyle's law, temperature constant, and then Charles law, pressure constant, and then for pressure law or Gay-Lussac law, that would be volume constant. Don't just memorize that. You have to understand it. Then it will be easy for you to explain the whole entire term. All right. So over here, we're gonna be talking about pressure, volume, and gas volume. Okay. So one thing that I want to remind you guys about is for pressure, the SI unit that we're going to use is actually Pascal. And then for temperature, over here, the SI unit is in Kelvin. So the previous subtopics, the front subtopics, our SI unit that we've been dealing with is actually degrees Celsius. So in terms of degrees Celsius, we don't have to convert for the front part, specific heat capacity, specific latent heat. Latent heat is constant temperature. But for gas law, when we deal with gas temperature, we must convert degrees Celsius to Kelvin. If you don't convert that to Kelvin, then you might get it wrong already. Okay, so then after that, volume we actually use meter cube. All right, in chemistry, volume you use ml. All right, but in physics, most of the time when we talk about volume, we will actually use meter cube. Okay, the SI unit of it. All right, so let's get back to here. So for Boyle's law, pressure is inversely proportionate to the volume. Okay, so when pressure is inversely proportionate to the volume, do take note on the graph over here. All right, so if we are talking about pressure and volume, then it will be an inversely proportionate relation. Okay, if you are considered 1 over volume, the inverse is volume as a term itself, then pressure is directly proportionate to 1 over the volume. All right, then this one, PV is actually from this formula. Okay, so I hope that from the videos that I've sent in that I did last time, you guys already understand how to identify Boyle's law, Charles' law, and pressure law. So those of you who just came in, I'm actually just a very quick recap. All right, please do note that today we'll have disturbance. Yes, wait, hold on. Okay, so for Charles' law, all right, Charles' law, the way that I memorize it is actually Prince Charles. All right, so because he's a prince, he will have to withstand a lot of pressure. Why I spell S pull up. Okay, so he has to withstand a lot of pressure from the family, from the imperial family, and then from the media, and then from a lot of sides. So Charles' law, you have to, when it has to withstand a lot of pressure. So for gas law, under Charles' law, the Charles pressure is being kept constant. Okay, so when it's being kept constant at a fixed mass, the condition must be there. The volume of the gas is directly proportionate to the temperature. Okay, so volume is directly proportionate to the temperature, but please do take note on one thing. This graph of volume against temperature, this volume is meter cube unit, but the temperature unit is in Kelvin. All right, the temperature unit is in Kelvin. Because here, as I mentioned just now, gas law, they need to talk about the SI unit. SI unit for temperature is Kelvin. All right, so whenever we play around with gas law formula, we need to make sure that the unit converts from degrees Celsius back to Kelvin. All right, so then for pressure law, because out of the three law, pressure, temperature, and constant, pressure constant is for Charles. All right, temperature constant is for Boyles. If I'm not wrong, Brian and also Darren is co-host. Help me to admit whoever that requests. And then finally, volume. So volume will be remaining is actually pressure law. All right. As I use the word in the video, in order to memorize volume constant for pressure law, I talk about the what was that already? Pressure cooker. Pressure cooker is actually a type of pot that once it's being covered, it is actually being locked. So when it's cooking, when the temperature increases from the bottom part, the whole entire pressure inside the cooker will actually increase as well, but the volume is kept constant. Okay, So unless one thing unless they have a small little release button at the side there, where normally it will be very noisy okay. So that is actually for pressure law. So pressure law, the volume is kept constant. The other name for pressure law is actually Gay-Lussac. It's actually a scientist name over here. All right. So here for pressure law, the pressure is actually directly proportionate to the absolute temperature. All right. So please take note, it's not directly proportionate to the temperature, but directly proportionate to the absolute temperature. So you will notice one thing. Okay. What do you notice here? When temperature is involved in the relation, it's a directly proportionate. When temperature is constant, pressure will be inversely proportionate to the volume. All right, notice that. When temperature is involved inside the situation, all right, when temperature is involved, it's a directly proportionate. Here also, when absolute temperature is involved, it's directly proportionate. But when it is inversely, when temperature is fixed, it's constant, then it is actually an inversely proportionate equation. So I hope that is one other method for you guys to memorize that. And then for pressure against temperature graph, this temperature must be in Kelvin. Okay, so what happens that if it's not in Kelvin? What happens to the graph if it's not in Kelvin? So if the graph is not in Kelvin, pressure unit in Pascal, but if the temperature is actually in degrees Celsius, okay, then the graph would be a linearly increasing graph with the intercept at negative 273 degrees Celsius. All right. If the temperature is in degrees Celsius, then the graph line will actually cut at negative 273 degrees Celsius for 0 Pascal. Okay, so please do take note for gas law, for Charles law, and also pressure law, the temperature is absolute temperature with the SI unit as Kelvin. Okay, so let's go next. This is the kinetic theory of gases. Okay, this is actually how the gas behave. Okay, so I think I did mention this inside the video that I asked you guys to watch before this, so I hope you guys have already watched it. Those of you who just entered the class, good evening. Can you please enter class point? Is at the upper right corner of my slide. All right, the class point code is here at the upper top corner, so please enter. All right, so I'm just gonna go next. Can I go next? Are you guys okay? Do you need me to explain some more on this? Yes, no? Ta-da.
I'm okay, too.
You're okay. You're definitely okay, Rebecca. What about the rest? Rest okay, No response? Okay, no response, then I'm gonna proceed. Now, absolute temperature. Absolute temperature is something that you guys have to be aware. Absolute temperature is measured in Kelvin. All right. So we have the word absolute zero that I want you guys to be alert of. Absolute zero, all right, it is the lowest possible temperature to date, all right, to the actual date right now in 19 December 2022. The lowest possible temperature that they detected is actually negative 273 degrees Celsius or 0 Kelvin. Okay, so at this point, volume and pressure of gas is zero, kinetic energy of the gas molecules is zero, all the gas molecules are stationary. All right, even if it's solid, all right, solid situation also, it is not vibrating at all at 0 Kelvin. Okay, so absolute temperature, the graph is if it's a volume versus absolute temperature with a unit Kelvin, it is a directly proportionate graph. So can I ask this question right now? You can respond me inside the Google Meet chat. This graph belongs to which law? Volume against temperature. This graph belongs to which law? Boyles, Charles, or pressure? Charles law. Why is it Charles law? Why do you think that it's Charles law? Temperature? Temperature is directly proportionate, okay? But pressure law is also temperature directly proportionate, ma. Good. Rabika's answer is correct because this graph is a volume against temperature graph. Pressure is not inside this graph. So which means pressure is constant. When pressure is constant, that's Charles' law. All right. Don't because seeing that the temperature is written there, so it's considered as Charles. All right. The main reason is because the y-axis is volume, the x-axis is temperature. So it is the pressure is not inside the equation. So that's why it's actually Charles' law. Okay. But if it's volume against temperature at degrees Celsius, it's not a directly proportionate. This graph is known as linearly increasing. So it will intercept the x-axis at negative 273 degrees Celsius. All right, not at 0 Kelvin. Okay. So this is actually pressure law or Gay-Lussac's law. So pressure against temperature directly proportionate if it's Kelvin. But if it's in degrees Celsius, then it's at negative 273 degrees Celsius at 0 Kelvin. All right, so what I want to bring your attention on is actually the word absolute temperature and absolute zero. Okay, so let's go next. I'll just skip this one first. When I have time later on, then only I come in. This is the question that I've sent in just now. I said I want to discuss question today. I'm gonna mute this music. So check back on your own working that you did just now that I asked you guys to actually print it, or you can actually look from here. What answer is this? All right, diagram 4 shows air trapped in an empty container floating in the sea at noon. So during nighttime, the volume of the trapped air is reduced. So which law explained this situation? Charles, Boyle's, pressure, heat law. Pressure law, which means you guys are saying that the volume is constant. Okay, so I have 12 people responding, 18 people in class point, but there's 21 people inside Google Meet. Those of you who just entered, please enter class point at this corner here. All right, type classpoint.app and then enter the class code 47118. All right, so while still responding, I'm gonna directly answer. Okay, I'm gonna wait for 2 minutes mark. So that's 20 minutes to go. 20 minutes, 20 seconds, sorry. All right, I'm closing the responses. So over here, before I reveal those who's actually responding, you all said 10% answered it's C. C is actually pressure law. Pressure law, which means volume is constant. And then there are 6 people answered answer B. All right. Answer B is actually Charles' law. So let's see what the answer would be. Now, in SPM exam, you're not allowed to take highlighter, all right? But you're allowed to bring your pen in. So I would advise you one thing: when you look into the question, don't just directly read only, but try to underline, try to circle, try to sketch out what is being written. So the question says air is trapped in an empty container, all right, floating at the sea at noontime, which means noontime is normally going to be very hot. Okay, during nighttime, here they are saying that nighttime and noontime, what's the difference? The temperature has dropped. Okay, and then it says that the volume of the air, trapped air, is reduced. So when the volume has dropped, when the temperature has dropped, the question is saying that the volume has dropped. So this means that volume is actually directly proportionate to temperature, which means that in this question, pressure is constant. So pressure constant means that this law belongs to Prince Charles or King Charles right now. Alright, so the answer is actually B, not C. Okay, so I would suggest you one thing, because from the experience of the Form 5 right now, Form 4s, I hope that when you get your paper 1, don't just read the question. Circle the questions, underline the keywords, and then write out what does it mean. Don't let your paper empty. Okay, so I'm going to go to the next question right now. I'm wondering, can you all hear the music if I switch it on? Can you hear music?
Yeah, we can.
Okay, so you want the music on or off?
On je lah, je.
Some on, some off. Darren, then you have to be selective lah, huh? You see, sound off. Okay, so I'll just off it then. Whoever wants to listen to music later on. All right, so the answers here are B so far. Which law does this graph obeys? All right, I'm gonna wait until the 2 minutes marker. Now, from 4s and from 5, I do want to remind you guys that always remember in SPM, alright, SPM question number 1, they emphasize 60% concept question. A part of 60% concept question, they also emphasize on applications. So when you want to explain applications or different types of situation, please do make sure that you need to make sure that your concept is strong. Don't just focus on calculation questions. All right, too much of calculation doesn't really help so much. Okay, so because most of the question on calculation is only 40% of the paper of paper 2 and 40% of paper 1, and the question actually not a lot over there. All right, so that's 2 minutes already. I'm going to close submission now. Okay, and one person responded it's pressure law, while the remaining 15% actually responded it as Charles law. So how am I going to have a look at this? All right, this graph is actually showing a volume temperature graph for a fixed mass of gas. So during gas, when you look at the word gas, please note that in exam, when you see the word gas, which means that we will talk about pressure. All right, we'll talk about the pressure of the gas, we'll talk about the volume of the gas, and we'll talk about the temperature of the gas. And from this graph, it says volume against temperature. So when volume against temperature, which means volume is directly proportional to absolute temperature, and that means pressure will remain constant. So when pressure remains constant, that is also again repeating the same law just now, Charles' law. All right, so this question answer is B, Charles' law. All right. Okay, I'm going to go next. So after traveled a long distance, a driver noticed that the pressure inside his car tire increased. The increase in pressure is due to, so first thing first, identify why the pressure inside his car tire increased. Whoever that answer question D, although I don't want to click the name and to see who actually answered question D. After long distance travel, the tire will become smaller. As usual, I will close the submission of this multiple choice question by the 2 minutes mark. So 16 people have already answered B. Friction between tires and road increase the temperature inside the tire. In another 25 seconds, I'm going to close submission. Those who just entered, the class point code is actually on the right hand side top corner. All right, I'm going to close the submission right now. Okay, so 17 people answered B. Now, for those who don't really understand or manage the timbuk correctly, okay, so I'm going to explain right now. Now, after travel a long distance, the driver noticed the pressure inside has increased. Okay, so again, here, how do I know that we are talking about the gas pressure? Because tire inside a car tire, there's nothing else other than gas inside. So when you see the question regarding gas, please note that we have to talk about the pressure, we have to talk about the volume, and we talk about the temperature. Now, we have to identify which is constant in this case. The tire, I'm sure you guys have seen a car tire before. So a car tire, the only place that you can actually increase, and let's just say it did not gonna batu or screw or whatever that can actually let the gas leak out. The volume inside the tire is normally constant. All right, volume inside there is actually constant. So we are talking about pressure law or Gay-Lussac law right now. Okay, so this means that pressure is directly proportionate to temperature. Okay, so when pressure is directly proportionate to temperature, it says that after a long drive, the pressure increase will definitely because of the temperature, the absolute temperature has increased. Therefore, let's find for the answer. Don't just directly see B and then circle B, cross check the answer, because in actual SPM case, answer A, B, C, D is very closely related to each other. So you have to make sure that your choice of answer is the absolutely correct answer. All right, so friction between the tires and the road increases the number of air particles in the tire. This is not possible because the tire is actually enclosed. The volume is constant, so A is wrong. Friction between the tires and road increases the temperature inside the tire. This is definitely because the friction will create heat energy. The heat energy will actually heat up the gas molecules inside there, causing the temperature to increase. So B is correct, but we still need to cross check our answer for C and D. Long distance traveled causes the tire to expand. When the tire expand, it means the volume also expand, which already go against of what our first initial analysis is, which is the volume constant. So C is wrong. And then D, long distance traveled causes the tire to become smaller. Not really possible for in this case. Normally when it long distance traveled, the tire becomes smaller means tire pancit already. Okay, so D is definitely wrong. So the answer is absolutely correct, is B. Okay, so please make sure cross check your answer carefully. All right, I'm gonna go next question. Those of you who just entered, please enter class point. Click classpoint.app. If I'm not wrong, it should be app lah. And then after that, the class code is on the right hand side top corner, 47118. Question asked right now, which graph represents Boyle's law? I have already 25 people inside the Google Meet, but there's only 20 people in class point. So do and come in so that we can discuss the answer together. As usual, I wait for 2 minutes, so that's 1 minute left to go. "17 people answered A. What happened to the remaining 4? Alright. Closing submission in 5, 4, 3, 2, 1. Alright, so Boyle's Law, actually not majority, all of you actually answered A. So for Boyle's Law, we are talking about temperature constant. Temperature constant, when the temperature is constant, the other two is actually directly proportionate to each other. So pressure is inversely proportionate to the volume. Therefore, the only graph that is inversely proportionate is definitely A. B is a horizontal straight line. This is actually constant. This graph is decreasing linearly. And this graph is actually not directly, because it doesn't intercept at origin, so this is actually linearly increasing. Okay, so the answer is definitely A for this case. Alright, let's proceed to the next question. A balloon filled with gas is released into open space and fly upwards will eventually explode. Alright, hydrogen gas is inside the balloon. It will actually fly upwards. Alright, and eventually it will explode. Why? "15 people responded already." Alright, 17 people. 5 more person haven't responded. 4 more haven't responded. So all the answers right now coming in is saying that the pressure inside the balloon is higher than the outside. Alright, that's less than 5 seconds to go, which I'm going to close soon. Those of you who just entered, welcome in. Class point code is at the right hand side top corner. Alright, I'm going to close submission. Okay, everyone answered, 19 people actually answered that the main reason the balloon filled with hydrogen gas is released into our open space and fly up will eventually explode. When it's actually filled with hydrogen gas, obviously the volume is going to be constant. All right, so when the volume is constant, okay, the density of it will increase upwards. So The air from outside enter the balloon, definitely wrong. Atmospheric density increases. This is wrong because as you go higher, the atmospheric density decreases, not increases. Okay, so B is definitely wrong. Hydrogen gas is easily combustible. The question actually says explode, not becomes how is it, get on fire or whatever. So D is definitely wrong. So the actual answer is that pressure inside the balloon is higher than the outside, which means that the gas pressure of the hydrogen gas is greater than the surrounding atmospheric pressure. So that's the reason why it will explode. Okay, so the answer for this question is definitely C. All right, next question. These are all the small questions that usually come up, but students always get careless mistake. So that's the reason why I picked out these questions for you guys to actually discuss further. Now, Boyle's law states that PV equals to constant value. So which graph represents the equation? I'm going to cut down from 2 minutes to 1.5 minutes. So Form 4, I'm actually doing partially doing the syllabus, and also partially I'm teaching you guys how to answer the questions already. Yeah. So do take note later on when we are discussing the structural question. You want to know your marks faster, then make sure that you write your answer properly according to standard. Alright, so I have another 20 minutes to go before I close submission. Those who want to answer, please answer quickly. Those who just came in, class code for this class point is at the right hand side top corner, 47118. Alright, closing submission. Okay, now Boyle's law states that PV is constant. If you notice, all the graph is pressure against 1 over V. When PV is constant value, this means that P is inversely proportionate to V. If we considered the graph of pressure against volume, then it would be a inversely proportionate graph. But if we considered a pressure against 1 over V, 1 over V as a term as its own, then it's going to be a directly proportionate graph. So all this graph is 1 over V. Therefore, the best answer is actually A, not C. All right, so I hope that clarifies. Okay, next question. Diagram 11 shows the condition of a plastic bottle which initially contains hot air before and after being put into basin of ice. The above situation can be explained by Boyle-Charles pressure. So is it pressure law or is it Charles law? Definitely not Boyle, because hot air, ice, that's temperature. We see that majority students is answering Charles law, meaning means pressure is constant. But there's still 3% who answered pressure law, meaning volume constant. 4% answering volume constant. Fifteen seconds before I close submission. Alright, closing submission. Let's see who got it correct, the 4% or the remaining 15. Okay, so here let's look at the question first. Condition of a plastic bottle which initially contains hot air before and after being put into a basin of ice. So here the temperature has dropped. Okay, then can you notice one thing? They specifically did not cover the cap. If they did not cover the cap, which means gas particles can come out, can go in. All right, which means one thing, this is definitely not volume constant. Okay, so when we're talking about gas, again, pressure, volume, temperature. Right now, it says that the temperature has dropped. All right, because from hot air into ice, that's temperature dropping. And then look at the size of the plastic bottle. Initially, it's normal size and then it get wrinkled up, crumpled up. So which means the volume drop. When the volume drop, temperature drop, the pressure definitely is constant. So when pressure constant, which means we are talking about Charles' law. All right, so this is actually how you should learn how to analyze in exam. Okay? Okay, let's go next question. I gave quite a lot of objective question. Hope to be able to discuss some subjective structured question later. Sure, what if the paper print the diagram as black and white? Ian, in terms of soalan pintas, which means your this year final year paper, and also trial SPM, and the actual SPM normally is colored. Alright, normally it's colored. It's only internal exam that is prepared by me is going to be black and white. So if it's black and white, I will make sure it's grayscale. Grayscale means you can see it more clearly. I won't give you a picture that looks very black one. So I have 14% answering right now. I still have 30 seconds to go. Isn't the question already done? Yeah, meh? Oh, yeah, ho. Thank you, Erica. So if the questions is already done, then I'm gonna skip this question already lah, huh? I didn't notice that I repeat the question. Thank you, Erica. Okay, let's go to structured question right now. Structured question, this question is fill in the short answer, which means you have to type in. Later on is directly screenshot your answer. All right. So this question, diagram 2.1, shows an air bubble produced by an air pump in an aquarium filled with water. So what is meant by pressure? Okay, now I understand one thing. This question probably the Form 4 tak berapa ingat how to answer. Okay. Force exerted per unit area, force per unit area. Okay. Those who answered, which means you already prepared and searched for the answers already. Okay, so let's see. I have to change a little bit for this question. Main reason is because last time in KBSM, this question of heat is actually learned as chapter 4 and chapter 3 is actually learned as pressure. Okay, but you still can answer that because you have some basic from Form 1 and Form 2. Okay, don't worry regarding this. So it's all of us are still learning together right now. Okay, so pressure, yes, the answer is force exerted per unit area. So all of you are actually giving me the correct and same answers except for Adelia. Too advanced already. All right, total force exerted on the wall of the container over the area of the container. Okay, while you guys are actually answering that, I'm gonna close submission for a while for here. Okay. Now, in this situation, right, when they ask what is meant by pressure, they are actually asking for the definition. Okay, they're asking for the definition. This question, Rabika, just now in the afternoon, she did message me regarding this. Because previously in KBSM syllabus, the heat chapter was learnt after the pressure chapter. But for your syllabus of KSSM, they actually shifted the pressure chapter to Form 5. Okay, so when they shifted the pressure chapter to Form 5, right, this question at the current situation is a little bit not so suitable already that I noticed just now when Rabika asked me. So this question I have to shift and change to another question right now. But anyhow, what is meant by pressure? What you mentioned was correct. In terms of definition, pressure is force acting per unit area. All right, you can also write the answer as pressure, but you have to spell it out, equals to force over area. You can write this answer here. Those of you who don't really know how to write the answer in full, you can actually write the in terms of formula like this. But if you write P equals to F over A, this is not acceptable. You need to spell out pressure and spell out force and area. Then only it will be acceptable. Certain definition we accept formula if memang the definition is the formula. All right, so like for pressure, this is the formula. Like momentum is a product of mass and velocity. So momentum, you can also write mass multiplied by velocity. This is also accepted. But if in case like force, they ask you what is meant by force, you're going to say force is the mass multiplied by acceleration. This is going to be wrong. All right, because the definition of force is not this one. Okay, so if the actual definition of that physical quantity is memang formula based, then it's acceptable to write to spell out pressure equals force divided by area. Okay, so I hope this one for Form 4 you are aware of it. Okay, so let's see. Ignore this one first. Okay, now this question I'm just going to teach you guys how to answer it first. Okay, so ignoring this. Okay, the question for this question is to compare. So I'm going to use this question to teach you guys how to compare the questions properly. Okay, so please do take note. Now, the first question in the next round, let me just close submission. Okay, the question asks based on diagram 2.1, okay, compare the water pressure at level P and Q. Okay, so very quickly, just to let you guys know, for water pressure, the deeper it is, the higher the pressure. All right, deeper level, water pressure is actually higher. So, which means if from the surface to this point and from the first surface to point Y, all right, Y is deeper. So, if Y is deeper, then the water pressure at Y would be higher. Okay, so I'm going to teach you guys how to write the answer properly. So please don't say that, oh, I'm already Form 4 and Form 5, the question is too simple, so I have to answer a little bit more changgay to show that I'm Form 5. No need. The question says, what is compare the water pressure at level P and Q. So first thing I'm going to do, I'm just going to write water pressure here. All right, then I'm going to look at a question for P and Q. P is up here, Q is down here. So from the surface down, Q is deeper. P is actually much more lower. It's much more shallow. All right. So which means the pressure at Q is higher. Therefore, all right, pressure at level Q is more than level P. Full stop. This is the answer that I want to see in exam. All right. You copy back what the question says, water pressure, and then you look at the question to determine which pressure is more, which is less. You don't have to explain too many stuff, please. The answer is just one line. It's a 1 mark question. I just want to see one sentence. Okay, so the next question says compare the volume of the air bubbles at P and Q. Okay, I'm going to do something before. Ignore the class point, please. Okay, because I want it to stop in a way. All right, volume of the pressure. So let's take a look at the volume. All right, this volume of the air bubble is small for Q, but P here, the volume is bigger. So the answer over here, ayo, can you just give me one quick minute? Just give me one quick minute to remove this. Okay, so just now the volume, okay, copy this back, volume of air bubbles. Don't interpret yourself, don't be to show that you are very smart. Just copy back volume of air bubbles at P is more than Q. You write any other method, I'm going to give you a 0. Okay? Don't interpret so much. Just follow what it says. Okay. Now, if you want to explain more clearly, the top part I'm talking about, Q is more than P. Right now, P is actually more than Q. There's another way for you to actually explain this is to mention regarding Q also. So volume at air bubbles at Q, because here top also Q ma. So at Q is less than P. It's the same answer as above, it's still going to be accepted. But the main reason why I want to write this is because the next question is asking me to relate the pressure exerted and the volume of air. So they're actually asking us to compare what we wrote at the first two part. And over here, you can see that Q, water pressure at Q is more, but volume of air bubbles at Q is less. So how do you relate? In this type of question, when they ask you to relate or they ask us to state the relationship from based on these two sentences, based on the diagram, do not use, I repeat, do not use directly proportionate. Do not use inversely proportionate. Do not use linearly increasing or linearly decreasing. Because these four terms can only be used for graph and equation. Here, there's no graph, there's no equation as well. So we cannot use the word directly proportionate, inversely proportionate, linearly increasing, or linearly decreasing. Okay, what can you write? All right, use the method that the sentence that I always use, which is, because here I'm talking about Q ma, when Q is more, the volume of Q is less. So I write pressure uh pressure increases, volume of air decreases. All right, or you can say as the pressure, or not as the pressure, the more the pressure exerted, the less the air volume. All right. So this is actually how you're supposed to answer a structured questions uh, relating or state the relationship. Chung Wei said the greater the pressure, the lesser the air. Can. No problem. Okay. Just don't write directly proportionate, inversely proportionate, linearly increasing, and linearly decreasing. Okay. So in structure question, unless you see a graph or an equation, then only you can state this four statement. Whether the question is relating, uh, deduce, all right, deduce a relationship, relating, this answer use back like this. if the question asks you to compare, use wording, which is more, which is less. Don't go and calculate the value if they give the value. The word compare actually only asks you to state whether which one is more, which one is less, or is it the same. Okay? So name the physics law involved. We are talking about pressure and volume. So the only thing that's not inside this question is what? What is not in the question? What is not being mentioned in this question? We are talking about
Temperature.
which is temperature. So the law that is constant temperature is Boyle's law. Please be careful with the apostrophe S. You spell boy wrongly, you spell Charles law wrongly, you spell pressure law wrongly, you get 0. Okay? If you spell the word increase wrongly, I won't penalize you. But if you spell the physical quantity, the law, the principle name wrongly, that's where you get your 0. Haha. Okay, so I'm gonna go next. This question also I'll have to skip this question because this question needs the pressure or water pressure question. So this question Form 5 can try. Form 4, because this is a Form 4 class, so I'm not going to discuss this question in Form 4. Okay, so I'm going to go to the next one. All right, so in this question, the next question, number 5, shows a reading of Bourdon gauge before the piston container is being pushed inwards. So this is a short answer, which means that the Bourdon gauge measure what? Gas temperature, gas pressure, or gas volume. So just write inside that, does it measure temperature, pressure, or volume? Two minutes mark, huh? So I have 9 responses already. I have 30 seconds to go. So for everyone, it's actually talking about pressure. So far, those responded, 12% responded, also responded as pressure. If you haven't read the question, you can actually read the question while we are doing it. Alright, so it's already almost 2 minutes, so I'm going to stop here already. Okay, so here, all right, how am I going to analyze? Definitely I know the answer is pressure, but I'm going to show those of you who do not know how to answer in case this is the first time you're looking at the Bourdon gauge. Okay, so look at the question. Diagram 5.1 shows the reading of Bourdon gauge before the piston of the gas container is being pushed inwards. 5.2 shows that it is being one before, one after being pushed inwards. So before I go into the rest of the question, I'm going to analyze. I'm already starting to analyze it already. So Bourdon gauge, if you look at the unit over there, it's in kilopascal. Okay, so kilopascal, Pascal is the unit for pressure. Okay, Bourdon gauge is the scientific name for your bicycle pump punya scale. So over here, all right, so this is actually measuring pressure. So Bourdon gauge obviously measure the gas pressure. Then after that, what else am I going to analyze first? Okay, so I can see over here that the first picture shows before the piston is being pushed inwards. So you can see the volume is a lot. And then you look at the number of molecules 1, 2, 3, 4, 5, 6, 7, 8. Here, 2, 4, 6, 8. So this is actually telling us that the mass is constant. Okay, because there's only 8 molecules, but that one is just me analyzing now. Okay, you don't have to calculate that actually. Then here, look at the volume of the piston. This volume is actually quite big. This volume is actually small. Okay, and then we look at the Bourdon gauge. Bourdon gauge here got 0, 15, and 30. It's very important how you actually read the thermometer, the scale. Okay, so here the 0 scale is at this corner. So initially it's in between 0 to 15. So when the volume is actually high, this pressure is actually low. All right, the measurement of the Bourdon gauge is low. And then over the other side, you see that the arrow is between 50 and 30. So this indicates that the pressure is high for this area. So what you're saying here is that the pressure is inversely proportionate to the volume. Meaning means mass is constant, volume is being manipulated, pressure is being recorded, temperature is missing from this term. All right, so the temperature here is constant, telling us that this is actually Boyle's law. Okay, so I'm teaching you guys how to analyze the question. So we're going to go to the next one. It's actually image upload. All right, so for those of you who have already did the question, you can just directly screenshot and upload it to the class point. For those of you who don't have, you can actually start writing and start typing. I'm giving you guys a little bit more time to answer this question right now. I know some of you haven't had the opportunity to actually write this question down, so I'm going to give you guys around, I'm going to close the submission at 5 minutes, so try to answer as much as possible that you can. All right, the question is actually inside the Telegram group and the WhatsApp group for Form 4s and Form 5 respectively. All right, so go and get this done, written down, and then send it in. Are you guys okay? Okay, I'm starting to get answers coming in already. Do you need a little bit more extra time before you actually submit it in? I'll probably wait for 5 responses. Alright, before I continue on with the explanation. Explanation plus discussion. I'm gonna stop the lesson at 9:30. So whatever questions that can be discussed today, it will be considered already. Okay? So do try to hurry up. Any other responses that can come in? Whoever that has already done like halfway through, you can actually submit the answer straight away already. Thank you, Ray. One more, please. Alright, thank you, Ian. Okay, I'm closing the submission already right now. Okay, now I'm gonna show you my answer first. Alright, then only I'll discuss through their questions, their answers. So the question says observe diagram 5.1 and 5.2. Compare the volume of the gas in the container. So first thing first, alright, I'm gonna write volume of gas in container. Then I'm going to look back at the question. The question volume of 5.1 is actually greater than 5.2. So volume of gas in container for diagram 5.1 is more than diagram 5.2. All right, so that's the answer. Reading of the Borden gauge 5.1. Okay, because I want to make a comparison very clearly. So over here, I'm going to talk about, since I mentioned about 5.1, so I'm going to look at the pressure of 5.1s comparing to the pressure of 5.2. So 5.1, the pressure, the arrow is in between 0 and 15. 5.2, the pressure arrow is in between 15 and 30. So which means in diagram 5.1, the pressure is less. So I'm going to say that over here it's talking about, it asks you to compare the reading. So when they ask you to compare the reading, don't go and play smart and write the word pressure. Okay, so you have to write reading of Borden gauge in diagram 5.1 is less than diagram 5.2. They didn't ask you what is Borden gauge. They did ask what is it being measured, so it's pressure. But because the question asks you to compare the reading of the Borden gauge, don't say the pressure in diagram 5.1. You have to mention back the word reading of the Borden gauge. Okay, so compare the gas molecules inside the container. So you can just mention, you can actually write the word same. All right, you can actually just say that the number. I'm gonna write short forms to make it faster. Number of gas molecules is the same. All right. Because it's the same, you don't have to write a very long answer. You write the word same also, it's still going to be acceptable for structured. All right. Based on your answer in 5B, 5B means this whole part, state the relationship between the volume of gas and the reading of the Bourdon gauge. Okay, so whether to deduce, Tongzhen asked, can just write same. For here, this question in section A, yes, can write same. All right, but in section B, you cannot. Section B, you have to write the whole thing. Number of gas molecules is the same. Okay, all right, so here the question asks, state the relationship between volume of gas and reading of the Bourdon gauge. So that's the reason why I wrote both 5.1, because volume of 5.1 is small, but the reading of the Bourdon gauge in 5.1 is less. So I'm going to say over here, um, as the diagram, replying to Tongzhen's message, diagram 5.1 and 5.2 is the same, can, acceptable. All right, as the volume of gas, I'm going to talk about 5.1. Volume of gas is more, so increases. As the volume of gas increases, okay, the reading of Bourdon gauge decreases. All right, so that's my answer. You can write the more the volume of the gas, the lower the reading of the Bourdon gauge is acceptable also. But I personally prefer to use the word increase and decrease. All right, name the physics law involved. We're talking about volume and the pressure being changing, so the temperature is constant. So obviously this is actually Boyle's law. All right, so this is my actual for answer scheme. All right, so I'm going to go and check their workings right now. So Ian's working is first. Volume of gas in diagram 5.1 is the same as diagram 5.2. Ian? Yes, Ian. I forgot to change. Okay, so too bad. You only got one chance before you hand up the answer. So sorry, yeah. Okay. Reading of Bourdon gauge in 5.1 is lower compared to 5.2. Number of gas in diagram 5.1 is the same as diagram 5.2. Okay. As the reading of the Bourdon gauge increases, the volume of the gas increases. So this is wrong. It's supposed to be increase and decrease. So here is wrong. All right, let me just tutup this. Name the physics law involved. Ian, I cannot see your answer for physics law. Okay, so I'm going to go next right now. All right. Adelia's answer, volume of gas in diagram 5.1 is more than diagram 5.2. You want to write so long also can, acceptable. You just want to write volume of gas in diagram 5.1 is more, full stop, also acceptable. You want to write is more than diagram 5.2, also can, acceptable. All right. So reading of the Bourdon gauge in diagram 5.1 is less. All right, good. The number of gas molecule inside the container in diagram 5.1 is the same. Good. The smaller the volume of the gas, the higher the reading. Okay, acceptable. And Boyle's law. Technically, Adelia, there's apostrophe S. Okay. So if I'm not that strict, I will accept this answer. Okay. But Form 4 normally I mark more strict. Shinyan's answer, volume of gas in a container in diagram 5.1 is greater. Reading of the Bourdon gauge in diagram 5.2 is greater. The number of gas molecule inside the container are equal. Okay. Greater the volume of gas, the lower the reading. Okay, acceptable. Boyle's law. Good. Rabika's answer, volume of gas in diagram 5.1 is more than volume of gas in diagram 5.2. Now, please be very careful. I've seen students, I'm not talking about Rabika's answer, I've seen students writing 5.1 is more than 5.1. So please be careful when you write, okay? Reading in diagram 5.2 is higher than the reading in diagram 5.1. Number of gas molecules in diagram 5.1 and 5.2 is the same. As the volume of gas increases, the reading of the Bourdon gauge decreases. Okay, good. All right, so all these are very good answers. Ray answer, container in diagram 5.2 have less volume than Ray, I'm going to discuss your answer. Try not to rephrase the sentence, Ray. The question asks, compare the volume of gas. So you just have to mention volume of the volume of gas in diagram 5.2 is more or less than 5.1. Don't rephrase. To the rest of you also, do not rephrase the question. I know you guys are from 4 and from 5, but this question is a for lower order thinking question for lower achiever to score. So we will not accept if you rephrase the answer too much. Okay, try to use back the question. So technically this is still correct lah, okay? Borden gauge 5.2 have a greater reading than Borden gauge in diagram 5.1, okay? Both container have the same amount of gas molecule, okay? Greater the volume of gas, the lower the reading of the Borden gauge. Be very careful. I almost see it as lever. Lever. So if I see it as lever, right, this question would be wrong already. So please make sure you guys write properly. Boyle's Law, correct. Okay. All right. So up to here, I hope you guys are clear on how to do the questions already. Okay. So let's discuss this one last question. All right. So I'm giving you guys around few minutes to upload to try to do the questions and then to upload your answers. Can I have at least 3 answers submitted in before I discuss? Okay, I'm responding to Xuyang's question inside the group. He asked, can I write the greater the volume of gas, the lesser the reading of the Borden gauge? I'm not an English teacher, but for me, I will accept that because I understand that the volume increases, the reading decreases. But be very careful on the verbs that you use to describe the physical quantities, because sometimes the verb that you use will indicate the opposite of what you want to express. All right, that's why normally for me, when I compare, I prefer, when I relate, I prefer to use the word increase and decrease because it's very straightforward, but still can be acceptable as long as logically the explanation is still the same. Okay, the only part that will trigger problem is that depth of water. All right, so Shuyang, your answer still can be acceptable. The greater the volume of gas, the lesser the reading of the Borden gauge. All right, I have Rabika's and also Shinyan's answer. Anyone else? I know normally the two of them will give me the answer faster one. Can I have one more answers, please? Or else I'm just gonna use Rabika and Shinyan's answer to discuss. No submission? No submission, then I'm just gonna use this. Okay, I'm going to close the submission right now. Okay, now let's look at the question first. Name figure shows the setup of apparatus to investigate the relationship between pressure and temperature for a fixed mass at constant volume. So we know this one is actually pressure law right now. All right. So over here we have a stirrer, we have a round bottom flask. Okay, I'm gonna explain this a little bit since I'm seeing this question here. In case in the exam they might come out this question whether SPM for Form 4s or finals, mid-years or trials or SPM later on. Now there is a stirrer located inside here. Okay, the main purpose of a stirrer in physics, right? Whenever we measure the pressure or the temperature, we always have a stirrer inside the beaker. The main purpose is so that you don't use the thermometer to go and stir the water inside, which I've seen in your Amali tree. All right. So the main purpose of the stirrer is to make sure that the temperature throughout the whole entire water, the beaker, is constant. Okay, you're not supposed to use the thermometer to go and stir inside. All right, especially for physics, you're not supposed to do that. Okay, so here, all right, name the instrument labeled Y. So this is a Borden gauge. So obviously Borden gauge. Be very careful when you spell Borden gauge. All right. Sketch a graph of pressure against temperature in degrees Celsius for the experiment above. Extrapolate your graph to show the absolute zero temperature. So the graph should be this is pressure and temperature. We know when it's related to temperature, it will be directly proportionate. All right, but that is if it's an absolute temperature. But here, the temperature is actually at degrees Celsius. So this graph is supposed to be linearly increasing, and you have to extrapolate to show negative 273 degrees Celsius or 0 Kelvin. So I need to see this graph. All right. I don't think so. This is supposed to be 3 marks. Normally, a graph would be 3 marks itself. Okay. Then to sketch a graph using the relationship of pressure and absolute temperature. So the second graph is temperature in Kelvin, pressure in Pascal. All right, directly proportionate that passes through zero. And then finally, state the relationship between the two variables in B2. All right, so the relationship is P supposed to state. So pressure is directly proportionate. All right, pressure is directly proportional to temperature. Oh, I should say one thing, to absolute temperature. And then write a mathematical equation for this relationship. So the mathematical equation is P over T equals constant. All right. So this question should be 1 mark, here 3 marks, here 3 marks, and then here got 2 marks. So this is 6 mark question already. All right. So I'm gonna check Rabika and Shinyan's working right now. Pressure gauge, Borden gauge, pressure gauge. Okay, I can accept this. Okay, and then Pascal, theta degrees Celsius, -273. Okay, I can accept this. Pressure, temperature, Kelvin, 0. Okay. Pressure is directly proportionate to the absolute temperature. Okay. Shinyan, they did not ask you to state Boyle's law. So they only ask you to state the relationship. So until here is sufficient enough. All right. The second part, no need. And then the equation that they want is only until here. Okay. So the rest of you, please do take note. All right. I'm not going to check later. Okay. I know Shinyan is already doing it. So she changed the degree Celsius to Kelvin already. So which most probably the answer is going to be correct already lah. Okay. So let's look at Rabika's working. Pressure gauge. Okay. Pressure, temperature, degree Celsius. Extrapolate. Good. 3 marks. Pressure, temperature, Kelvin. Good. 3 marks. Pressure increases. Absolute temperature decreases. I still can accept this. Okay. So, yep. Alright. So Rabika and Shinyan's working is both correct. So good job. Okay, so I think I'm going to stop here for today. Is there any other questions that you want to ask me?
Yeah, sure. For the like the question, I think it's C3 or something.
C3.
It's like the one after this is C, and then
This
the
one.
one after that is C3.
Here.
Yeah, that one. What's it in referring to? Because it says explain your answers in 5C2, but we don't have a 5C2.
Wait, did I think I didn't rearrange the question properly. This one should be going somewhere on top. Piston is being pushed inward, so which means I didn't arrange the question carefully. If I'm not wrong, this one should be here. 5C2. Rabika? It's supposed to continue from here. You
Uh,
see? Hak cipta bahagian pendidikan menengah Mara. I didn't rearrange the question properly. See down here?
oh, okay, okay,
Uh,
okay.
I think that one should be clearer for you right now.
All right, thanks, sure.
Because I took the questions out from different place from last time syllabus and the recent one, so I'm gonna rearrange the flow so that it's easier for you all to see and easier for us to discuss. So I must have forgotten about this part lah. Okay, so any other questions that you guys want to ask me? No, so far okay, yeah. I'm going to stop recording first.